In this video we'll be looking at recurring decimals and how to convert them into fractions. So first of all, what actually is a recurring decimal? So we've got three examples here. A recurring decimal can come in three different forms. So the first one is the most basic one, where we just have one repeated number. The second one, we have two repeated numbers that are next to each other, represented by these dots here. In the third example, we put the two dots around the outermost numbers and it repeats everything within them forever. So let's look at an example. How can we convert 0.12 recurring into a fraction? So first of all, we want to label 0.12 or 0.121212 so on as x. If we multiply that by 10, what's going to happen is this decimal is going to shift one place to the right. So we're going to have 1.21212. And you're going to see the numbers after the decimal place look fairly similar, but not quite the same just yet. So what we're going to do is we're going to times by 10 again. So again, this decimal is going to move one place to the right again. So 12.121212 and so on. Now what you'll notice is the original number and this number have the same decimals. And now that they're the same, we can subtract them from each other. So if we do 100x minus x, we know that's going to make 99x. But also that's going to be 12.121212 minus 0.121212. And what this actually does is it cancels the decimals from each other. So we're just left with 12 take away 0 ultimately, which is 12. Now we have this equation, all we have to do is take the 99 and divide it underneath the 12. And for a bit of simplification, both of these numbers divide into 3, so we can divide both of those by 3. Okay, so now we've turned the recurring decimal into a fraction. How do we do it the other way? So we're going to use the same example, and we're going to take this fraction here and convert it back into 0.121212, because we know that that is the answer to that question. So the best way to do that is through bus stop, I find. So we want to do 4 divided by 33, as that is what our fraction was. So we can put the 33 on the outside, and whenever you've got a number that is smaller that you're dividing into, it is best to put some zeros after the decimal point. And we'll see why in a minute. Because when we get to here, how many 33s go into 4? That would be a 0 to start. So we carry the 4 across. Now how many 33s go into 40? Well, that would be 1. And then we put the 7 there, because that's how many's left over. So now how many 33s go into 70? Well, we know we've got 33, 66, so that's going to be 2 with 4 left over. And then you can kind of see a pattern forming already. So 33s into 40, we get 1 with 7 left over, 2 with 4 left over, and it's just going to create the same decimal again. And we put a decimal point in there, and that is our original decimal. So I hope that helped, and thank you very much for watching.